first, for this session, we will continue our discussion, and I will explain a material about more deep about machine learning and deep learning technique, yeah, for supporting the data science activities or analysis. And the second is I will explain about what our final project for your final final test, yeah. So because we are now in the week, in the end of the week, yeah. So maybe about two or three times we will have a session, and then you will have a final test. So I will explain what is the plan for the final test. So, but before that, today I would like to give you some explanation about why we need a machine learning, and then why we need the deep learning technique for supporting our data science activities or analysis. Yeah. So for today, we will learn about what is it, why we need it, why we need this course, and then this subjects, and then the objective is if giving you a framework to have a logical thinking about how we use the machine learning, not in the technical side actually, but mostly in the reason why we need this technique. And the second is the purpose is you have the point, what the goals and the purpose when using the machine learning and deep learning things here. And I will give you some example about the project that we are on the running to do that one, and then hopefully it can give you some insight about the the use of the machine learning and deep learning in the data science. And I think one of the groups, DAFA groups, say that ready for presentation. I think I will give some time, yeah, after I explain, and then DAFA team will be present. Yeah, so hopefully we can enjoy this session. Yeah, so let me present this materials. Wait. Okay. Yes. So hopefully you found my presentation, and this is what we want to discuss today. And what we want to discuss today is about the machine learning and then deep learning things here. How we capture and discuss about it in the data science here. Because it's something sometimes it's very different. We have another point of view when you discuss a machine learning as a subject of machine learning itself, and then and machine learning or deep learning in the point of view of data scientists, yeah, of data science. I mean, yeah, so that we have a very significant difference on it, yeah. Because when we discuss about the machine learning as theoretical basis, so we learn about the algorithm, that how we train the data, and then build a models, and then use the model to predict the next data, and then we have some evaluation on it, and then we have the accuracy and some score for the performance, and then we will discuss that machine learning work well. And it's also happened in the deep learning, and then in the deep learning we will focus on how we we try to analyze the features based on the hidden layer that we can discover from the data. And then we I think we also develop the model on it, and then with the new perspective of the algorithms, mostly using the neurals, some algorithm basis, and then we have a prediction for the analysis and so on. But when we see in here, but I'm very interesting with the word of definition in the Wikipedia, and then I think we can identify several term or word that very important for us to understand that machine learning and also deep learning actually is not only just algorithms, but this is also how the way we solve some problem that we discover, we found in the data set that we try to analyze this. Yeah. So in here you can see that machine learning state that the scientific study of algorithm and statistical models. Yeah, I will stop in here first, because in here we can see the explanation about this is like scientific study. So it's not only just development of the algorithms or implementing some algorithm, but the most important thing is scientific study. So machine learning is the process how we study something in the scientific basis. Yeah. So when we see data set, it's not only just data set. This is like a problem that we need to solve in the scientific way. Yeah. So in the scientific study, of course, in the machine learning, we discuss about not only just algorithms. In here, we can find that the first is always algorithm. This is in the form of machine learning. But the most important thing is using the statistical models. So in here, we can realize that when we discuss about the machine learning, actually we very close to discuss about the statistical things. Yeah. So this is that like we formalize the statistical models, and then and how we can perform this algorithm and the statistical model can be worked effectively in the very specific tasks, yeah, that we want to run in the computer, for example. But the most important thing is about the algorithm and statistical will be form of the models. So in the machine learning, the main focus is how we formalize the models, that the model can be solve some issue in the data set. It can be for prediction. We can see from projection. We can see from discovery or something else. So in here that we can see in here that when we using when we discuss in the data science, so when the question is when we using the machine learning, so of course it's not only just about we try to finishing the job of the as data scientist, but the most important thing is where we need to know that the reason when we're using the machine learning in the data science process is when we need the models. Yeah. So if we doesn't need the models, actually we doesn't need to implement the machine learning. So I need you to keep thinking about it and then to understand about this point of view, because it's very important. So because it maybe like in the another discussion, sometimes people say that of course if we are a data scientist, we exactly need to deal with the machine learning. But actually it's not only just a machine learning, yeah, because in the data science is a very wide technique and method that we can deal without the analysis. But when we need the models, yeah, for the data on the problem that representing based on the data, we need to model to solve the data. So in that time, we need a machine learning. Yeah, so that's the most important thing. So when we continue about discussion, of course, to develop the model is not easy for machine learning. It's just not like model is not like like puzzle. We just combine a piece of set of piece of puzzle, and then we have the view of the models. It cannot be like that, yeah, because in the machine learning we know about the training data. That the training data is very important, because this is the first process how we can formalize the candidate of the models, and of course we build based on the mathematical models, and then using the sample data that we divide as a training data, yeah. And then it's very important because it is in order to make prediction, yeah, or of decision on it, yeah. And the the implementation is very wide. If we can see this one, I think all the data, it will be need a model to analyze more deep, and then to analyze more more challenging, yeah, and then to find to come up with the insight, for example. So that will be very challenging. But in here, when we related with this discussion, I think we will realize that machine learning, because it's models, so it will be computational statistics, yeah. So if one of you join also in the course of the computer philosophy, for example, computer science philosophy, you can see that all the things that need the need the computational function. So it appears, yeah, because we are in the data model came from the statistical models. So it's mean we need the computational statistics in here, yeah. Especially not only just computational statistically, but also the optimizations, yeah, on the mathematical models. So in here, that you need to realize that when you're using the machine learning, you need to, as data scientist, you need to realize that the first model that you came out with your result in the first iteration, for example, is not always the best models. So you need to optimize the model into the fit models. So in here, that it's very important to understand that we need to do some iteration on the models. We need to run the training model again, and then we need to do some enhancement and so on and so on and so on, and that's really very important. So the problem is now, I think that when we see like data scientists work today, they only focus on to produce a model, and then they use for all the data they want to predict. Yeah. But unfortunately, yeah, you know, that will be the problem, because the most important thing is to find out the model that fit with the data. But it's okay for your thesis, for example, yeah, because you only have I say that the first version of your data set, yeah. But if we go to the real company or a real world, I think the data will become every time. So in that time, in every time too, we need to fit the models. Yeah. So that will be the nice one. So that's why most of the machine learning will be the main function is to predict something in the futures. Yeah. So because the prediction and the predictive analytics will be the basis for do some projection and also for cognitive analysis. Yeah. So that will be the first things. So in here, I want to summarize that machine learning is a process. Yeah. The process that we need to realize not only just one process instantly finished and then giving us the good models, but the most important thing is this is the iterative way, yeah, to produce the fit model for our problem, to find out the best solution of our problems, yeah. So that the machine learning too, yeah. And in the simple terms, yeah, we can say that machine learning is using historical data to make a future prediction. So that's why the machine learning is very fit and very compliant when deal with this type of data, especially historical data, yeah. For in our world, yeah, time series data and so on. And then the machine learning will be built the model on the historical data to predict, yeah, to do some predictions. Yeah. I think we understand about it. As human, we also do same things. Yeah. So for example, when you have some historical data that in your life you already have some historical event, so you can use your historical event for predict something happen in the futures. Yeah. And then for the taking training data, building model on the training data, using the model to make the future prediction. So we really rely on the training data. So that's why it's very important to set up the training data or data set in the very good quality of data sets, because if we not do that one, it will be very difficult for us to have a good prediction of models. So that's why in the implementation, the training data maybe will have about 70% of the data set that we want to use to analyze this. Yeah, you can imagine that if we only have 30% of data that we use for build the model on the training data process, so it will be not reflecting anything, yeah, for the model. So it will be very difficult to use the model for the future prediction. And it's also happen if the data set is not balanced. For example, we have a sample of data that for example, for sentiment analysis, the sentiment analysis is the positive result is only a 10, and then the negative if more huge. So it will be very, it will maybe is only work good for sentiment, for negative sentiment analysis only, yeah. So but for the positive, it will be very difficult for the model to work with the data. And the most important thing is making the machine learning the partner in the data. Yeah, so that would be in the simple term of how we can see the machine learning on the data science view, yeah, point of view. Yeah. So that will be very important. So in here, I think before I go to the next slide, you can see the image. So this is like the picture that gives you some summary view how we see the machine learning. Yeah, a lot of path, a lot of journey, a lot of process, and then we can find the models in the middle of the data set. Yeah, so that would be important for you. So in the numerical data, especially that we deal with the data that in the form of numerical, so it will be using for the machine learning can be using for the credit risk model, for example. Yeah, identifying risky customer before offering of loans, for example. Yeah, based on the behavior and so on. And then we do some marketing analytics. Yeah, for any from the, do you receive any marketing calls? Have you ever received any marketing call for your car, for example, and so on? And then you can decide to choose to buy a new car, for example. And then retail sales analytics, and also the advanced one is using for fraud analytics here. So that would be one of the example on it. And of course, in the non-numerical data, for example, for image and video data, we can use a lot of things here. For face recognition, using image as input data, and object recognition, and then pixel is the input of data, and then using digit recognition. Yeah, and then now we are in the autonomous car. Yes, car.
Nice.
Using video data as an input and so on. So that would be also one of the challenge today. Yeah. So I think we have a broad implementation scheme on the how the machine learning can be can be used for the implementations. Yeah. But you need to realize that the image data is also numerical data. I think in the human vision, we see the image as image, but actually in the computer vision, we can see in here is as numerical too. So when everything is in the numerical data, I think it can be produced. Yeah, it can be analyzed on the machine learning and etc. Yeah, so that would be the clue. Yeah. So I think you need to also realize that machine learning tasks are usually described in the term of how the machine learning system should be processed on an examples. Yeah. Yeah, an example is collection of features that have been quantitatively measured from some object or event that we want the machine learning system to process. Yeah. So the implementation category for the machine learning, we can do some classification. We can also do some regression, machine translation, and also the anomaly detection. So that would be the nice one. Yeah. In here, we can see that if we related with our previous discussion about the type of the data science analytics. So in here, the machine learning can be worked in the predictive analytics and also in the cognitive analytics here. So if we go to the descriptive analytics, we only use the statistical way. Yeah? In the prescriptive, maybe advanced statistical analytics. Yeah. But when we do some prediction, some predictive and cognitive, exactly we will need the machine learnings. Yeah. So let's discuss more. So in the machine learning itself, actually is very very rapidly develops today. Yeah. Yeah. I think I think in the another course lectures also give you some explanation about it. Yeah. But today, yeah, at least we can find at least three major type of the machine learning. Yeah. In here we have the unsupervised learning, and then we also using the supervised learning. Yeah. And also the the common one, and then the new one is the reinforcement learning that now become also the major of the method on the machine learning. When we see the unsupervised learning, actually we have two type of the focus. The first is dimensionally reductions. Yeah. So and then the second is clustering. Yeah. Dimensionally reduction is how we can defined in the data set, we can reduce a dimension that may be very complex dimensions. Yeah, so we can specify more detail, and then more maybe the number is not large, but it's very easy for us to supporting our journey for analysis. So in here, we can do some feature elicitations. Yeah, this is common, I think, for some of the analysis today. And then we do some structure discovery in here, and then meaningful comparison, and also big data visualizations. Yeah. So we can try to find, to reduce the dimension of the data. And in the clustering, it can be used for the recommended system, targeted marketing, and also customer segmentation. Yeah. So it will be like, clustering, yeah, to grouping some data that have common features. Yeah. And then in the supervised learning, we have a classification, and also we have a regressions. This group, the classification, it can be used for fraud detection, image classification, customer retention, and also diagnostic things. Yeah. And in the regression, we do some forecasting, prediction, process optimization, and new insight. And then in the reinforcement learning, we have a real-time decision, game AI, learning tasks, skill acquisition, and also robust navigation. So these pictures, I will want you to understand is, you can see in here, every method in the machine learning have a different type, and also in the different type, they also have a very unique purpose, yeah, or objective. So in here we can see that when we have some problem, for example, we need to first identify what the problem is, and then we can choose the right method, and then in the right algorithms. Yeah, so that will be the important thing. So you can use this image as your early stage formulas to classify the algorithm that you want to use for your problems. Yeah, so I think that will help you. For example, when you maybe in the short time, you will try to do your thesis, and then you will have for example a question, what algorithm that you need to use for your thesis, for example. So don't be like the first mistake. Yeah, the first mistake of the data scientist is placing the algorithm in the first place. So I think you need to placing in the first place is about the problem. What is the problem? You need to identify the problem first on the data, and then after you can identify, and then you can analyze what exactly the algorithm that I need to implement to solve this problem. So that will be the way how we do the data science. Yeah. If you are the machine learning engineer, I understand that maybe you will more focus on the algorithm, develop the algorithm to enhance the performance and so on. Yeah, because you doesn't need the problem. You just need to enhance the performance of the algorithms. Yeah, so that will be different perspective. Yeah, as data scientists and also the machine learning engineers. So that's why in the startup, in the information technology company, we divide these two style of the employee. This is the data scientist, and this is the machine learning engineer or deep learning engineer, because it's different actually. Yeah, in that point. So when we have this one, actually when we combine the unsupervised learning, the supervised learning, and then the reinforcement learning, you will have a cognitive capabilities to analyze the analytics in the next steps. Yeah. So let's discuss more deeply. When we see the supervised machine learning process, especially in the supervised machine learning, actually the process will be very tight. Yeah. The first is we need to ensure that the training data, especially in the first of the raw data as data set, it should be very clear, yeah, very clean, and then and have a high quality. So that's why training data, it should be select and then also identify in the very good manners, yeah, and then we need to have a test data we do some data labels, we do some data cleaning, yeah, and then create a structure of the data, and then split the data if necessary. Yeah, so that would be the most important thing. So in here's that I would like to give you some insight that very important in the data science process. When we insert the garbage, I think we will have the result of analysis also is garbage. Yeah. So that's why data set is very important. So this is, I think, the weakness now to today, especially us in Indonesia. We doesn't have a very a lot of high quality data set. Yeah, for especially for us. Yeah, we still very depend on in the Kaggle or in the some of the data set that have in the internet. Yeah, but in our own itself is very limited. Yeah, so that would be the problem. So that's why I think as data scientists you need to have that skill. Yeah, that you need to provide your own data set. So my suggestion is, if you working for a company in the futures, yeah, in the near futures, maybe you can suggest with your company, if as data scientist, you need to have your own data set, see, because it's very important. Because when we have our own data set from our system or our environment, it's mean we will very close with the model that fit with our problems. Yeah, so you can let your, for example, fraud detection model using the data set that established in the Kaggle from the US or something, because maybe the fraud style is very different with our own environments. Yeah, so that will be very important for us to see that one. So if we want to detect our fraud, of course we need to have our own characteristics. Yeah, so that is important. And the next is using a feature engineering. So that we call it the feature engineering because we need to do some feature extraction in here. We need to slicing the data into piece of features. Yeah. So in here's the metadata of the data, and then the information about the data is very important to find out, and then be the feature that we need to know about the data. And then we also need to have the sampling and coding also in here. Yeah. And then we need to have the algorithms. Yeah. In the algorithm, it's not only just we just pick the algorithm and then implement for build our models. Yeah. For example, call the library and so on. But the most important thing is we need to detect the information from the features that we has discovered from the previous step, and then detect if we have a sum of these features, how we need to have these algorithms. This is fit or not? Yeah, something like that. So you need to have a comparison and do some benchmark in your thesis. In your thesis, this is the function of you need to read a lot of papers and then write down in your literature study for detect the information. And then after you have the algorithm, sometimes the algorithm need to adjust, yeah, based on your own features. Why? Because we need to continue and repeating unless perfect. It's mean we need to enhance the capability of the algorithm, and then we have the fit algorithm for our cases. Yeah. And then after that, we develop the model, yeah, do some process, and then do some testing, training, and then in the next we have a production. Yeah. So in here we have a prediction, verification, and so on. So what the mean of the supervised? Supervised will be implement in this in the three first step. Yeah, in the raw data, feature engineering, and also the algorithms. Yeah, so that mean especially when we do some training data, we will have a supervised based on the expert or another data that can support as our training data. Yeah, and yeah, of course, if we do some, we combine with the unsupervised. Yeah, the unsupervised is very different. Yeah, because the unsupervised, it's mean that we have a several step. Yeah, the first step is provide the machine learning algorithm uncategorized and unlabeled input data to see what pattern it finds. So we let the algorithm to find their own patterns. So that will be the nice one, yeah, actually, yeah. And then we do the observe and learn from the pattern the machine identify. Yeah. So based on the pattern, we will have you know, some of the models or pattern and use for predict in the future. Yeah. So that will be very important. So this is like for the clustering is, yeah, identify similarities in group. Yeah, if we have the features on the data that has similarity, so that's why we can group into one single cluster. But for in the anomaly detection is also if we have a group of data that not connected with the common one, so it's means it's the anomalies, and then the anomaly will be identified as fraud, something like that. Yeah, so that will be our actually what you can understand about the unsupervised. You can see that it's very different with the supervised machine learning. So if you have a data set for your thesis, for example, and the data set is not is unlabeled, yeah, there is no label in there. We doesn't understand about the category itself, so you can go to the unsupervised, yeah. So using the some clustering or anomaly detection. So it will be very, of course, maybe the question, how if I want to go to the supervised? So it's mean you need to invest your time and hire the expert to do the training data first. So to giving the identification of the data and labeling the data, and then you go to the supervised data. So something like that. For example, you capture the Twitter data, but unfortunately, your Twitter data, there is no label on this is positive or negative sentiment. So you hire the expert of linguistics from the faculty of language, for example, and then you let them to give the label. So that's mean you go to the supervised machine learning. Yeah. So that will be the how it's work. Yeah. So it's very tricky actually when you do that one. So you need to very clear about it, and then you know need to very you know very smooth on the move. Yeah. So on the we also have the intersection between supervised and unsupervised that we call the semi-supervised learning. Yeah, in the semi-supervised learning, of course, we have a label data, maybe a lot very small of label data. We have 1 million data, but unfortunately we only have 10,000 data, and then that label, and then we use for that. So what we can do? So we can do some semi-supervised learning. Yeah. So from the label data, which we make a train the model with the label data, and then we will have a model to predict the unlabeled data based on the label data, the pattern on the label data. So we use the training model to predict label from the unlabeled data. So we use the model to label it to make a label data from the unlabeled data. Yeah. So that's why we call this is a pseudo label data. Yeah. And then we try to we compare with the label data, and if compromised, we can retrain the model with the pseudo and label data set together. Yeah. So the pseudo labeling, I already now working with one of the students in the master program to do that one. Yeah. Because, for example, I have final national test for the SMA in Indonesia about 17 million data, but unfortunately the label data is only about 100,000 data. So it's very small. So we need a lot of, maybe 50% of the 7 million data should be labeled. So to do that one, we go to the pseudo label data. So that will be the challenge also, because we cannot, you know, if we push into all the label data, so I think we will have a lot of time to consume, and then to proceed on the label data. Yeah, so that will be not effective and not efficient. So that's why we can use the semi-supervised learning in here. And now we also have the reinforcement learning. Yeah, the reinforcement learning is I think the method that is also promising, yeah? Because in the reinforcement learning, we also have input raw data, and then we set an environment, yeah, in here actually. to to have a selection of algorithms and then choose the best action. Yeah. And then we do some reward and reward system on it. If the model and the algorithm works well, and then we have the output. In here, we can see that this is like a combination between the supervised and supervised and semi-supervised learning going together, but we let the algorithm, make a best action for themselves, yeah, to resulting the best result for them, yeah. So that we call the reinforcement learning. So if we discuss about it, I think we can see from the sentiment analysis. Yeah, for example, I will pick in here. I think you already know about it. The sentiment analysis have a sum of class that may be positive, neutral, and negative things. Yeah, maybe we have also 5 or some things. Yeah, so if we have some word from the Twitter, from the comment features in your blog or in your e-commerce platform. So we will have some challenge how we analyze this word, yeah. So how we do automatically, yeah. So that's why in sentiment analysis we have some text input, the previous slide that I showed to you, and then we using the tokenization, and then we do some stop word filtering, and then negation handling. And then also do some stemming, classification, and then sentiment of class. Yeah. So that would be the process of sentiment analysis, for example. In here, there we can see that sentiment analysis is work on the classifications. Yeah. So that will be the next one. So in here, in the pre-processing, we need to have in the input, we need to tokenize all the input. Yeah. This is the illustration. So we tokenize all the word that involved in the input. And then we do some stop word filtering. So the word that not really have meaning, so we need to to cut off from the data. And then we do some stemming also. This stemming is like transform the word into the core word. Yeah. So we eliminate the word that need stemming actually. Yeah. So and then we also need to have some of the negation handling, yeah, because some of the word is have a the word sometimes have a play the word, yeah. For example, this in here is I am not very happy, in here say I am not very happy. So in here is like if we select the eliminate the I am in here, so not very happy will be negative. But if we eliminate all these things, it's very happy, it will be positive. It's actually it's like a context, yeah. So it's very important to see the context of the words, yeah. Because especially as in our Indonesia, we also play some word to state something, yeah? So that will be also the problem, yeah. So hopefully we can catch the core meaning of the words, yeah? So that's very important. And then we do the feature extraction using pack of word, yeah. So we need to see that if we have a lot of document or tweet, so we will have a 1 tweet, 2 tweet, and etc. So but in years we will build some terms in years, yeah. So every word that we found will be list, and then we will be marked by 0 and 1, and then we will have a stop word list 2. So it will be like a pack of word for our data. So that's very important. So you can see in here that we need to make some pack, yeah, that consists of a lot of word that from the data set, yeah. And then we go to the machine learning techniques. I think I already explained to you, yeah. So that's why we need to split the data into the training data and also the test data and also validation data. So this is like several algorithms that we can use in the supervised learning algorithms. Yeah, we can use the k-nearest neighbors, make bias, decision tree, support vector machine, linear regression, and also logistic regression. Yeah, so that will be some of the supervised learning algorithms that you can find. In the deep learning, we also have neural network, convolutional network, and recurrent network. I will explain later. So that is the very important factor that we need to understand, that data in the supervised learning is very very depend on the training set data that we implement, yeah. And then this is because this is very important to train and tune your model, yeah. So that's why in the to ensure that we have a good model on the data, so we're using the cross validation. Yeah. Cross validation is like we try to combine the combination of the training data and test data, and then we can see how the performance on the models. Yeah. So that's why what our suggestion is, when you have the original data, divide into k part, yeah, several part in here, for example 3, and then we can use the round one and the 2 training data and then 1 test data, and then we combine it, and then we can see there is any difference that very significant or not. If not, it means your model is good, is appropriate, and then we can use for the rest of the data. But if not, yeah, I think we can see which round that have a good performance for your data model. Yeah. And oops, this is the classification. So we bring the data that have a similar features into classifications. Yeah. So we have 2 things. Yeah, classification and regression. Yeah, this is, I think, have some in some point they have some similarity, but in the different point they also have a different point too. Yeah. So in here that classification, a regression is have some replacing the data in some of the chart, for example, and then we can see that where is the group of the data, and then we can divide into some of the classification actually based on the similarity of the number of k that we need to found. But in the classification, that definitely we want to divide the data based on the feature and the pattern that shown by the data. Yeah. So that will be the difference. Yeah. And we also have classification using the decision tree. So because we are using the decision tree, so it means we make some decision node in here that have some leaf node on the option, and then we try to bring the data into get down into the leaf node, and then we can found the models. Yeah. So in here, for example, we have some classification. For example, if we need to decide should I accept new job offer. So we have a salary at least, and then if yes, if not, yeah, of course it will decline. If yes, we have a new into the next category. We have a commute more than 1 hour. If yes, if decline. If not, it's mean like another criteria. For example, this is offer free copy or not, and so on. So there will be like theoretical things here in the decision tree. And also the classification is also using the support vector machine. It's not only just using the direct features, but also using the support the vector, yeah, or the margin between the boundaries and then the features that we can see. Yeah, so that's if the boundary and then the margin is acceptable, so it means we can split the data into 2 or 3 or more classifications. Yeah. So the important thing is, of course, all the model need to be evaluated. Yeah. So that's why we have the true negative, false positive, false negative, and true positive way to do some evaluations. So that's why we will have a precision. Yeah. This is like the formula to classify to see what the precision score on it. So that's why in here that we have a true positive, and then will be compared by true positive plus false positive. Yeah. So this is like positive side. But if you so that's why in the true positive we have a total predicted positive in here. So that's why we try to evaluate the positive side on this data. Yeah. So we also have a need to see the evaluation on the recall. Yeah? This is true positive and compared by true positive plus false negative. Yeah, so that will be the point of view of the recall. And also we have F1 measure here as result, because we can compare the precision and the recall itself. Yeah. So in the clustering or an unsupervised learning, yeah, we need to classify or divide the data in the very natural features of the data actually. Yeah. So yeah, and of course we need to see the select the node that represent the key, yeah, actually as the key of the cluster actually, and then we need to assign all of the object to similar centroid randomly. Yeah, so that will be very important to see the number of the centroid, and then we can cluster center updations, yeah, depending on the new cluster means, and then we can see the move of the object into the centroid, and then we have the cluster in here. Yeah, so that will be like very natural, because it's using the similarity and also the feature that definitely can divide the data into the different form. Yeah. So in the application of clustering, we can see this one. You can use in the recommendation engine, method segmentation, social network analysis, and then using search result grouping, medical imagings, yeah, and then also use the image segmentation and also the anomaly detections. Yeah, so that would be the use. So after that, we can go to the deep learning. Yeah, in the deep learning, actually, the basic of deep learning is rely on the artificial neural network. Yeah. So actually, neural network is one of the techniques in the machine learning. Yeah. But why we need this one? It is because of the object of the data sometimes have the hidden layers. Yeah. So we need to very carefully to take to identify the hidden features on the data, especially when we discuss about the data from the image, for example, image, multimedia data, and so on. If using the word data, the text data, I think it's not very, it's not have hidden layers, but image, sound, multimedia, and similar with that, it will be have a hidden layer. And of course, it's really complex and non-linear data set. We need several hidden layers, yeah. And so that's why the artificial neural network with multiple hidden layers is known as deep neural network. So in here is that we can use deep learning because we can find and identify the multiple hidden layers that we can discover from the data. Yeah. So you need to take a look again about the characteristic of data. If they have hidden layers, and so it means we need to go through to the deep learning. Yeah. So in here that deep learning is we have, for example, we have the artificial neural network with a single layer. It's not a shallow network, yeah. With multiple hidden layers, it's known as deep neural network. Yeah? So that will be the difference. But unfortunately, it's not just multiple hidden layers. Sometimes the type of hidden layer is also different. Yeah. So this concept of solving problem with multiple hidden layers is known as deep learning. Yeah. So if we using the multiple hidden layers, it means we need the high deep learning algorithms. So in here that you can see that one that shallow network is when we have this input and then we have the lot of hidden layers, only one hidden layers, and then we have the output in here. So that's why in here called a single hidden layer here. But in here we have more than one hidden layer, so it's more complex. Yeah. So that will be, we need the deep neural network here. Yeah? So that will be challenging in here. I will show you later. Yeah. So in here that a lot of experiments have shown that a deep network with less parameter perform better than shallow network. Yeah. So because we have a lot of have a lot of multiple or hidden layer is we have a lot of hidden layer. It means we can filter the data more deep and then more I call it more core. Yeah, we can find the feature that very core of the data. So it's very easy for us to analyze it in the very advanced way. And then yeah, it's very powerful, yeah, with sufficient number of hidden layers and node, we can fit a model to any type of data. Yeah. And then yeah, we have the power to capture any amount of non-linearity. Yeah. So this is like actually the you know the how it's work is same. We have the new data, we have the apply model on it, and then we have a get predictions. Yeah, this is the machine learning. But when we see this one, this is like one-way models, yeah. So because we only have model and then we can use the prediction. But sometimes the prediction can be right and also wrong, yeah. So that's why we need the feedback loop for respond and the prediction that may be right and also it's wrong, yeah. So that's why when we have the feedback loop in here, as new data, it will be we have the AI or artificial intelligence. Yeah, so it's very important. Sometimes because when we discuss about deep learning, the people will say that okay, this is the AI. AI would be need the feedback loop on it on this process. Yeah, it's not only just one-way models. If we are only one-way model, it's mean using the machine learning. Yeah, so when we get that one, so it's mean like we have the updated training database on the feedback. Yeah, so the feedback will be will be placed as new data set and add the data set, and then we have the update the model based on the data. So that means like iterative way how and the model will be grown. The model will be always developed. Yeah, because of the feedback of the data. Yeah, so that will be the things that we need to know. And the technique to do that one is a lot of things, yeah. So this is, I think, all of you already understand about it. So this is only the summaries for you. So a lot of things to do that one, yeah. So this is like the stage of the how we can analyze into the deep learning, yeah. Because if we go to the machine learning, so it's mean like the basic algorithm for regression, classification, segmentation. Advanced machine learning, neural network, SVM, random forest, boosting, and so on. But when we do the deep learning, we need the CNN, RNN, and LSTM, and also when we have the AI model, so we go to the deep Q learning, reinforced learning, and also Markov decision processes. So that will be the theory on the artificial intelligence things. Yeah. Okay. That's for me. That's from me about the material about our discussion today. So next, I will give you some example on the research that I still working on to using some of the subject. Yeah. So let me share with you. But before that, if you have any question, please you can state on your chat or open your mic before I display for you. Okay. Okay, so this is, I will, I think, no question before it. Before I start, any question? No, okay. Okay, there is no question for yet, yeah? Okay, so, yes, please?
Oh, no, not yet.
Not yet, okay. So this is like the example how I use the case to implement the data science side into some of the problems, yeah. So I still working on the COVID things actually until now, maybe 1.5 years from the last years. Yeah, I do some analysis based on the growth of the data, daily time series data, yeah. But now is already automatic now based on the big data engines. But I go to the next breakthrough, yeah. So I think you already know about the genus and the genus, and then how the genus help us to identify we are positive or negative on the COVID-19. But the most important thing is actually we have based on that case, yeah, from the genus best practices. I think we believe that actually our major, especially computer science, have a very big roles on today to solve a lot of problems, especially in the healthcare. Yeah, so I think using the smart devices, mobile and big data will be revolutionize healthcare. Yeah. So yeah, I think the Genius is one of the best example. Yeah. So based on that one, I believe that we still need to future forward. Yeah, working forward to find out the new approach on it. So today, actually, I built one of the application today with my group. Yeah, and then we can also see the same development in the different approach on the several countries. Yeah. I don't remember this one, but this is like this is startup, I think, from one of the Europe company, I think. But unfortunately, it's fake. Yeah. After it's run, have some investment. Unfortunately, it's fake because they claim that only one single tick of the blood they can analyze all the disease that occurs on the blood. Yeah, but unfortunately, it's not working well. And in the Israel COVID-19 saliva test give result in seconds. This is using the air, yeah. So that will be the next one. So we give the air, and then it will be test, and then give the result. This is the bread tonic. Yeah, I think it's from the Singapore. I do not remember the NUS or NTU. It's same with the Genius actually, using the bread, the air of the bread, yeah, for detecting the COVID-19. This is the device of them. Yeah. So that's also one of to show you how the future forward of the work on the healthcare, but using the machine learning and AI things. Yeah. So when I try to discover, I think many source of the data that we can use here. For example, I found a lot of journal and also the scientific paper that discuss with the tongue and the lidah. Yeah. So the image of lidah is very important. Yeah. So that's why when we go to the doctors, sometimes doctor want us to ask us to show us our mouth. Yeah. So they will see the lidah kita, and then for the side of our mouth, and then to see what the indicator when we have some illness. So it is also supporting by several scientific papers in the journal and conference that already use the tongue image analysis for health diagnostics. So that's why it's also interesting is analysis of tongue shape to identify disease by using supervised learning technique. So that will be one of the also very I think it's very good, yeah, to see about this development. So yeah, I think we agree all of us have this one this object in our body. So I think we can use for many things. And the most important thing is how we can make some tools to check we have a COVID or not, but very cheap. Yeah, in very cheap. If it can free, I think it's very free. If it can free, it's very good. Yeah, so that's why we can do. So what we do is, because we using the image of the tongue, and then we also we add some supporting data, and then we will have a data collection. So I think because our data is image and also text, so that's why we can see that we have the opportunity to have a lot of hidden layers on the image. Yeah, because we can see the shape, we can see the you can see, for example, the color, and then the mark of the tongue, and so on. So that will be the reason. In the first phase of development, what I and my team working on is to think about what are the methods that we can use for it. Yeah, based on the paper, based on our design, I think we agree that we need using the deep learning method for it. Yeah, why? Because we believe that the hidden layer exists on the image. So that's why we of course we combine. Yeah, not only just not only we also have some cooperation with the doctor in the hospital to have the data cleansing and preparation, and then give the label. Yeah, of course, giving the labels. And then we develop the data training, and then we make a data model based on the convolutional neural network, yeah. Because why we using the convolutional network? Because we have some some of the features on the convolutional network is have a decoders, yeah. So that will be very interesting to see this one, because especially when we discuss about the healthcare and diagnostic, the accuracy will be very major issue on it. So that's why we try to have the advanced algorithm on it. So it's not easy actually, because in our iteration until now we not have a very good result actually. So that's why we're not very confident to release now, yeah. But I will show you how we have this issue. In the result, we have the classification, and then recommendation and historical time series analysis. This is the supporting technology that we use here. We using a lot of technology using CRAS, and then using the PyTorch and so on. So this is like the image how we try to identify the hidden layers, and then giving some analysis on the image to identify. Yeah, so you can see in the original image of the tongue, for example, it will be like that one. So you need to capture your image and then send on the application, and then we will identify the the size or the form of the tongue. Yeah, so you can see in here, and then we try to identify the each features, the hidden layer. So we make some topography based on the color of the tongue. Yeah, so we have a segmentation and here. And then we go to the more detailed segmentations, and then we go to the some of the another segmentations more deep. Yeah, this is like a pixel-based segmentation, and then we will have a new form of the tongue that already identify as new features. Yeah, so in here will be add some label by the doctor. This is from the patient that positive COVID-19 or negative. And then it will be used for train the data and then test the new data. Yeah. So we also have a feedback. Also, if we found a new form of tongue because of new variant of the COVID-19, for example, it also will be inject to the data training and then give a new updated models. Yeah. So that would be the next one. So yeah, we have a lot of technology in here. Yeah. So it's very very complex, I think. Yeah. Yeah, this is the tools that we implement in the isolation room in hospital to identify the patients. Yeah, because we need to have a very limited, and the data we store to the lab SKG, and then yeah, unfortunately until now we only have about not a lot of data, because we're still working on the 300 and now maybe about 500 data. And then the accuracy, the model is 76% in the performance. It's not going well yet. Yeah. And actually, we have planned to reach this data, but unfortunately, is problem because now the government and hospital is not very open to the research. Yeah. So that's why. And now they're very restricted to access the patient. So that's why it's very difficult to find the data models and data training from the positive especially. Yeah. So that will be the next one. So in here you can see the implementation of the deep learning method on it. So this example actually will be one of your will be your final test. Yeah, I will explain now, but I will give you some description, detailed instruction for you in the ELOC as soon as possible. But for your intro, yeah. So I would like you from now with your group. Yeah, this is like group assignment actually, but you need to submit individually. You need to think about one of the object, yeah, a problem in the surrounding of the COVID-19 in Indonesia, and then to find a new data set, not only just data set like this one. Yeah, for example, it's not only just like data set like I already share with you, yeah, from the previous assignment, yeah. But the most important thing is I want you to find based on this one, yeah. So the point of view that we can revolutionize the healthcare. For example, last research I also found like using the image of the X-ray of the thorax. It's also you can use for it. So what I want to do, what I want to do for you is you doesn't need to collect the data, but you need to found, for example, like what I do. Yeah, you can see, you can discover from the research that already exists in the journal on the paper, and then you came up with the object that you want to identify, and then you design your approach, yeah, using the machine learning or deep learning things, and then you can identify which algorithm that you want to implement. This is very important because I need to see what your reason to do that one. It's not only just, okay, I just want to trial and error. No, in the data science, it's not trial and error, but you need to analyze which algorithm that's very appropriate with you, and then what the result that you want to see. And so that will be your you need to report on your final test. Yeah. So I think you can start from this week to try to develop that one, and then I will give you in the ELOC later for the instruction and also for the form that you need to write down your paper, your report, and then you submit to me in your final test. Yeah. So something like that. But from now you can identify which object that you can use for it. Yeah. You can use from the image of the tongue, from the eyes, for example, from the shape of the face, for example, or maybe in ETS they develop the some of the ketiak, yeah, something like that, smell of the body and so on. So I think that will be revolutionary. So I want to push you to think about some revolutionary idea to solve to have the contribute, especially when we this 1 or 2 years, last year and this year, we're still facing the COVID-19 issue. Yeah. So that will be your works. If you want to, if you can do until some small experience. For example, you only collect several data from the internet or from your friend. It will be plus for you. Yeah, it's not only just idea, but also you implement something. I think it will be also the good point for you. Yeah. So that will be my explanation for today. And if you have any question, please.
Sir.
Yes, please.
So what about the COVID and the additional data set? I thought you mentioned that those two would actually be the replacement for the exam. So
yeah. So that there is no exam actually for you yet, but you need to submit your report.
Okay, and for this assignment that you just mentioned, can we do this in a group?
Yes, actually this is group assignment. Yeah.
Okay.
So you can discuss with your friend, and then you of course you work with your friend, and then you write your report as group also, but you need to submit individually. Okay, thank you for the question. So I will give you some the detailed instruction later, yeah, for in the ELOC, yeah. Okay, I think I will go through to the next session. I think one of the team asked me to give time for presentation. Gabriela from Davasti.
Yes, sir. I will be presenting my screen in a minute.
I will close my presentation, please, yeah.
Can you see my screen, sir?
Yes, but
yes, the Gmail. So okay, yeah. So firstly, me and my team, so there's Gabriela, Arkan, and me, myself, Dafa, will be presenting two presentations. And the first one being the COVID-19 cases, where you assign an homework for us to do a descriptive analytics, but we also actually put the predictive on the COVID-19. And the second one, we're going to predict the additional data set that you've just uploaded a few weeks ago. So without further ado, I'll just pass this on to Arkan to talk about the data set of the COVID-19.
Okay, so as we know, from the original dataset that you gave, Mr. Mardhani, there are 5 sheets in the original datasets, which is one cumulative prof. Cumulative prof is a cumulative frequency of confirmed case in our province from 18 March 2020 to 19 April 2021. And then we have pertambahan per hari, which is a daily confirmed COVID case in our province. And then we have the third sheet, sembuh harian, daily recovered case in our province. The fourth is meninggal harian, the daily death case in our province. And then for the last, we have a summary, which is a summary of all the previous metrics, suspect data, testing data, and hospital data on 11th December of 2020. Next. So the next is we select the data. So basically we take a 5 province in this case, DKI Jakarta, Jawa Barat, Jawa Tengah, Jawa Timur, and Yogyakarta. For each city, we select 5 column, which is a date, cumulative confirmed case, daily confirmed case, daily recovered case, and daily death case. And then we combine all the data. Okay, next. So here is the example, the data that we have selected. This is our dashboard. So in the dashboard, we have total daily confirmed case, total daily recovered case, total daily death case, and we also have a graph for daily confirmed case and a graph for cumulative confirmed cases.
Okay, so continuing from what Arkan has delivered. So today, as we can see from the graph, for the daily confirmed cases, we can see that there's an increase from March 2020 up to January 2021, and we're going to explain about some of the events that contribute to the increase. And we can also see that the highest number of confirmed cases actually reside in DKI Jakarta, as we can see from the pink charts. And this actually also can be seen in the cumulative confirmed cases, where Jakarta has the highest among the other provinces. Second, we're gonna be discussing about some of the events that could actually contribute to the trend. So the first one, we have Eid al-Fitr in the 22nd of May 2020. So the part of the graph that is circled in orange, we can see that there's a momentary rise between 2 days with total daily confirmed cases of up to 684, with the highest one being in Jawa Timur. And then on the 9th of July, there's also an instantaneous rise, which we don't know the cause for it, because we've tried to look at for news or any events, major events that could actually contribute to the increase, particularly in Jawa Barat, because the highest one for that particular day was in Jawa Barat, but there wasn't any sort of news that talk about any events on that day. So we're not quite sure about the factor causing the increase. Third one, we're gonna highlight the October. So there's a slight declining month in October, but there's also this omnibus law protests on Jakarta. So as we can see, starting from August up to October, up to November actually, there's Jakarta has actually outdo the other provinces in terms of the number of daily confirmed cases, and probably one of the factors is the omnibus law protests. And We can also see that there's a general election in the 9th of December with a steady rise during the campaign, averaging to about 4,000 daily confirmed cases, the highest one being in both DKI Jakarta and Jawa Barat. And then we have actually reached the peak of the trend, which was actually achieved on the 16th of January with a highest number of 10,455, and this was actually most likely be contributed by the Christmas holiday and the New Year, the New Year Eve, because if we look at the data, it peaked at the 16th of January, which is like around 2 weeks after the holidays. So it kind of makes sense because the incubation for the virus transmission is about 2 weeks. But in the following months, from February up to the current date, we've actually discovered that the trend actually goes in decline, because probably the major factor for this is due to the vaccination, particularly on the 13th and 27th of January, in which our President Joko Widodo received 2 doses of the vaccine, and then from then it just starts to go in decline. So these are some of the trends of the matrix that we've discussed earlier about the cumulative confirmed cases, daily confirmed cases, and we can see that in most cases we see an increasing trend, and then now it starts to sort of slow down a little bit, shown by the less steep gradient in the recent days. But again, DKI Jakarta and Jawa Barat, particularly DKI Jakarta, is the highest, has the highest number of confirmed cases, with Yogyakarta being the lowest. And this is also another indication of the trends for the daily death case and daily recovered case. A similar trend is shown for all of the matrix. So which is a good indication, because even though that the daily confirmed cases is sort of increase quite significantly, but it's also followed by an increase of daily recovered cases. But for the daily death, it's not that huge of an increase. We can see that it's most likely it looks more flat for all of the province, except for probably Jawa Timur, yeah. Right, so we also presented a pairwise relationship between all of the matrix, and also a correlation map. And we can see that out of all the matrix that we've discovered, the daily confirmed cases and daily recovered cases has the greatest or strongest correlation between all the matrix. And this is actually going to be part of our further analysis by using machine learning modeling, which is actually going to be presented by Gaby about the daily recovered cases.
Okay, so first I try to visualize the missing value, and as my friend mentioned before, we use like 4 features right here, and we have like some missing values represented by the white parts, and if we take the value percentage of it, I think it's quite low, except for the daily death cases where it's almost a quarter of it missing. And to impute this, I actually use the median value, because the data is skewed, it's not normally distributed. And then from then we just split the data with the test size of 20%. Next. Okay, so here I tried using 4 different algorithms. The first one is the simplest one, linear regression. I use this as a benchmark so that I can determine whether the next model is good or not if compared to the simplest one. And also for the distance space, I use k-nearest neighbors, tree-based random forest, and the best algorithm XGBoost. And from all of these algorithms, I use hypermeter tuning using randomized search and grid search. Next. So the first one is using linear regression. Here we can see the train data and the test data around 71%. There's only like 1% of differences. And I try to evaluate the regression by using plot actual and prediction, and also the residual plot. From the residual plot, we can see that it is kind of unbalanced. I think it indicates that there's like a missing feature, which makes sense because we only use like 4 features. Next, and the next one is, it's the same. I use grid search, but with polynomial parameter. Why do I use grid search and combine it with polynomial parameter? Because it's a very simple algorithm, so it won't take much time, and we can see that it increases about like 3%, and the residual plot actually are more balanced than the previous one. X. Okay, from there I try to do feature importance, but I know since we only have like 4 features, we cannot just drop anymore because it will be too biased. And as we can see here, the one that is the most important is the cumulative confirmed cases, and the province actually, it doesn't affect that much. I use mean score decrease to see the importance because it is like agnostic, so it does not really care of what kind of algorithms it is. Next. And then for the distance base, I use k-nearest neighbors. I don't, even though it is very overfit, but I don't improvise it because I don't think it is appropriate for this kind of problem of COVID-19. It's too abstract, so distance base won't be a good problem. So I'm just gonna skip it. Next. And then the tree-based model, I use random forest with randomized search and grid search. Here we can see that it increases significantly. The test data, it's around 80%, and the train data, it's kind of overfit with only like 6 to 8% of differences. I think this is worth it because like the bias variance trade-off, if our model is too simple or has very few parameters, then it may have high bias and low variance. So we need to find like the good balance, and this trade-off in complexity is why there is a trade-off between bias and variance, and algorithm can be more complex or less complex at the same time. Okay, next. So here I use XGBoost. It actually only has difference of like 0.003. It does not have like that much differences, and the overfit, the differences is getting larger. So the best model that we have so far is the random forest by using grid search hyperparameter tuning. Okay, Dava.
All right, so that's the end of the first presentation about the COVID-19 data. Now we're going to actually present our recent assignment, which is about the additional data. But to be very honest, it was quite a challenge for us to actually discover the context of the data, given that the names of the columns were kind of vague and we didn't actually understand what the measurements were for. So we tried our best to implement the machine learning and deep learning models to predict the data set. So firstly, we have 5 inputs, so the air, abu, protein, lemak, and carbohydrates. And what we're trying to predict is all of the measurements ranging from 410 nanometer to 940 nanometer. So we have about 18 measurements. And again, this was actually quite vague. We didn't actually understand what the measurements were for. We tried to look out for information that would actually correspond to this information to the measurements, but still it was still unclear for us. So we tried our best to implement the models. So this is actually general information about the data set that we were given. So from 23 columns, we actually know that we actually discovered that all the data types are the same, which is float. And we also know that there is no missing data, so which can also be seen that all of the columns have 99 rows without any sort of missing or different number of rows, meaning that no missing data is present. So initially we tried to implement using the supervised learning because we want to cluster the data into certain groups. This is actually done by scaling the data set in the range of 0 or to 1, which you can also say that the data is being normalized. And then we actually apply the model, and then we plot the model into a chart. So again, this is a scaling. So we actually scale the data set into, ranging from 0 to 1 to normalize the data. And then we fit the model to the data set, giving us 5 clusters of the data set, because we actually want to use 5 as the parameter of the clusters in our k-means model. And this is actually the result of the model. And we can see that it's a linear graph, which divided by 5 clusters. All right, next we want to implement the supervised learning models using the long short-term memory. And this is actually done by firstly encoding the data set, and then similarly to the unsupervised data set by scaling the data and then put the model. And as we can see from the trend and test data, even though it seems like they kind of have a huge gap, but if we look at the scale, it's actually quite small, which means that our model, not only that it has the best fit, but also it doesn't actually overfit as well, so which is quite good. And this can actually also be seen by the RMSE, showing that it's very close to 0, actually, about 8.3% of error for the standard deviation. And that's the end of the presentation again. So thank you very much for listening.
Okay, great presentation for this group. I think the COVID-19 dataset you present the very wide and very impressive analytics. Yeah, so I think I can see that this team can implement all the things that we need to show on the descriptive analytics. Yeah, so that's cool. And the cool is the second data set that doesn't have any information about it, and then you can analyze in your own, and then you came up with the, I think, also good analytics too. So that's cool. So that's I think why I share these two kind of data set. The first is actually the COVID-19 is I think like well defined and well identified the parameter and so on. But the second is sometimes as data scientists we face a data set that we cannot know anything about it, and then we need to discover by ourselves about the data. So I think this is good and excellent. Yeah, thank you very much for this report. I think you also have submitted to ELOC, yeah?
Yes, sir. Yes, we've all submitted to the ELOC for both of the assignments that we've just presented.
Okay, thank you very much. I already accessed the file. So
thank you, sir.
I have no comment. Just congratulations. That's good.
Thank you, sir.
Okay. Okay. Any other groups want to share? I'm impressed with this group because have initiative to want to present in the first time. So that's cool. Okay. Oh, I think no way. Okay, if not, it's okay. I think the most important thing you submit the assignment. So if you can give the presentation, I think it will be plus, and you will have additional score for it. Yeah. And so for today, I think that will be our session. So please, I think we will go. We will meet again next week. Yeah, I will continue to give you some another material. It will be nice because the title will be storytelling. So the data science have a storytelling side. So I will explain to you, and because it's very important to know about the strategy, how we deliver the story of our analytics to the audience. Is very important and very impactful for us actually, yeah, as data scientists. And the second is I will check, or we will have discussion. So please prepare with your group at least the what is the data that will be or potentially will be used for your group to analyze for your final SAM. Yeah, so that will be you need to identify. If you have some example or some, you doesn't need to analyze first, yeah, but you need to at least identify, to find out what is the data and the description of the data. That would be nice to share with us, yeah. So we will have a discussion for it. So if next week I say that the group is okay, you have a cool, your data set is agreed, so you can proceed to the next step, yeah, something like that. So I think that's it for today. So for the student that not yet scan the QR, please scan your QR in here. So I think I will close this session. Thank you very much for your time, and see you next week, and enjoy today. Have a good health and also happy for today. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.